The electric universe is an amazing story, and it's my view that humanity, each of us, operates according to a story. And sometimes we're so attached to those stories that we'll go to war over it. Now, the EU story is, in my view, an interdisciplinary story which touches everyone at some point. In fact, the Electric Universe conferences have shown that we can draw people from all disciplines and all walks of life and inspire them. Because it is an inspiring story, and it got its start from my inspiration. The inspiration came from Velikovsky. That's not to say that everything that Velikovsky wrote was correct, but he, on certain techniques, this forensic technique of looking at so-called unreliable witnesses, the witnesses of the ancient past, you can actually draw from that evidence a picture of what was happening, and then you are faced with the problem of trying to explain it. And my role in all of this has been to look at the evidence that was amassed and then try and explain it. And that has meant dumping a lot of the cherished beliefs, the story that I was brought up with.
Well, sorry, just to interrupt. Maybe you do a little bit looking over here too, because all we're seeing just profiles through the whole thing.
Okay.
Thank you.
Mm-hmm.
Spread yourself around.
Complexity theory says that you can start with a set of simple rules and repeat those rules generation after generation, and within a very short time the complexity that arises from those simple rules can be quite amazing. But the other interesting thing about complexity theory, it says that you can't work backwards to deduce what those simple rules were in the beginning. Unfortunately, the story that we live by, the Big Bang cosmology, treats the complexity that we find now by introducing new forces and new particles, new entities at every turn in an effort to try and match the observations. The electric universe operates by trying to imagine what those original simple rules were. And the result of that has been a synthesis which allows us to get a grasp on how the universe really works in an electrical sense. It's very simple. You could teach this begin to teach it to primary school students, and certainly college students would grab it easily. But the other part of it is that it's not only interdisciplinary, but it shows how we're all connected. And I think this is the big story for the future, is this connectedness instead of the divisions that occur. This has been, as I've discovered, as you get to a certain age, you look back over your career and you join the dots, and I've been amazed to find that I actually began this journey around the age of 5 or 6 at primary school. In fact, I think I'll start at that point. Go back to my primary school. So this is my story. I was born in Melbourne, Australia in 1942. So in the 40s, I was at primary school in an outer suburb of Melbourne. The surroundings there were not what you call middle class. We didn't have much. My father was invalided after the war, and so we were living on a pension. But in those days, it didn't seem to matter. Everyone was more or less doing the best they could after the war. I had a favourite uncle who was a commando in New Guinea, and he introduced me to the telescope. He used to show me the moon through his army field telescope. He was also a very creative guy, and he made a beautifully constructed crystal set, which he gave me. So this introduced me to radio. I ended up making crystal sets to order for all the kids at school who wanted one. The other thing that he introduced me to was reading the encyclopedia, and so I had the habit of going to school, memorising having memorised all these facts and made drawings of eclipsing binaries and that sort of stuff, and boring the kids in my class with my discoveries. Somebody who made an impression on me too in those, or later on in school, was Sir Fred Hoyle, or just plain Fred at that stage, with his wide-ranging ideas and the fact that he didn't like the Big Bang. I've got a little quote there from his book. The Big Bang idea seemed to me to be unsatisfactory even before detailed examination showed that it leads to serious difficulties. When I got to high school, it was about halfway through high school, my father brought home from the military hospital a red-covered book, Worlds in Collision by Immanuel Velikovsky, and he said, knowing my interest in astronomy, I think you'll find this interesting. It wasn't just interesting. I'd never read anything like it before, and I think when you consider that it was a bestseller for many months running in 1950, that many other people thought the same thing. It drew together evidence which showed that the ancient skies were quite different to the ones we see now. And that was inspiring. It gave me another idea to work with. My first thought was, well, surely all my teachers can't have been wrong for all of this time. So I questioned people, and when I went to university, I went to the physics department, and this is the entrance to the Melbourne University physics department, and embossed in the limestone above the doorway are the words School of Natural Philosophy. Well, my view was that at university any question could be asked, nothing was taboo, and that you could expect a reasonable answer, or at least a statement that you don't know. That's not what I got. I found either avoidance of answering the question or outright hostility, and that really surprised me and disappointed me. So I stopped asking questions about Velikovsky, but I decided that as a science undergraduate I would also read books from the anthropology section of the library. And in doing so, I felt even more strongly that Velikovsky had made a case to answer, because I was reading books that he had not referred to, and yet the story that he had pieced together leapt off the pages. You know, myths from the South Sea Islanders and Middle India and places like that. So I felt that this dismissal of Velikovsky at the university was unwarranted and ill-advised, since I felt he'd provided good evidence that the solar system had changed within human memory. So I was working on my slides the other night, and lo and behold, there was an advertisement that came through from the National University. I come from Canberra, that's the national capital in Australia. And what it said was that Professor Lawrence Krauss presents the greatest story ever told so far. Now, I've witnessed Lawrence Krauss speaking to the experts, the astrophysicists, at the National University's Research School of Astrophysics. I'm in the great position of being only a 10 to 15 minutes drive from the top of Mount Stromlo, the observatory, and where they hold these meetings. So I've seen him in action. That's his book, A Universe from Nothing. The very title makes no sense whatsoever. The introduction, this is yet to happen, so I may actually attend this when I go home. The introduction is by Nobel laureate Professor Brian Schmidt. We actually had a set to in the national newspaper a few years ago, an amicable one, and I tried to organise a meeting with him to have coffee. This is before he got the Nobel Prize. Also, I should mention that Brian Schmidt is the Nobel Prize winner who was involved in devising another entity, dark energy, for the accelerated expansion of the universe, or at least that's their interpretation. I quote from the blurb that goes with this advertisement, and this is ironic. The real story of the universe is much more interesting and exciting than the unsubstantiated and bland myth pervaded by the ancients. I could hardly believe my luck when I saw this. And it's this kind of dismissal of any kind of history, the idea that science has reached some kind of pinnacle and you only have to deal with research over the last few years to do good research, is completely wrong. It's my experience that in order to find the answers, you have to go back and look at the historical controversies that raged often for decades or more, and look at how it was resolved. And usually it was on the basis of who was the most powerful politically or somewhere in the power structure in science, or it was just a case of a show of hands. And as they say, science isn't a democracy, or the science that we accept should not be on the basis of a vote. Professor Lawrence Krauss describes the remarkable scientific story that has led to the greatest intellectual edifice ever created by humans, the Standard Model. The strange thing is that we hear these mantras delivered by experts on television with no thought to the fact that there are so many problems that are unresolved in the Standard Model. But these are glossed over as if somehow we've almost got the answers. I think the thing about this is what I'm saying was reinforced, that this is all about stories. We need a better story. Big Bang cosmology, when you look at the history, sprang from mathematics, pure mathematics, and religious beliefs. So the Big Bang is a myth. Once upon a time, long, long ago, there was nothing, which exploded. So here we have nothing doing something. In contrast, the electric universe began by analysing global cosmic myths, and this is the inspiration that Velikovsky passed on to those who were inspired at the time. And for myself, I'm just grateful that I had the doggedness to keep pursuing it all my life. And as a result of the interdisciplinary nature and the number of scholars from all different fields, it's become an astonishing story that shows our real place in the universe so far. This is an example of the problem you have when your story differs from someone else's. Here we have Steve Crothers, another Australian by the way, who has presented at one of our EU conferences recently, and I believe also at the NPA. And he attended last month a meeting in Russia. As you can see the kind of titles there. And he was an early speaker, so what he had to say should have been quite relevant to everything that followed. It was flaws in black hole theory and general relativity. Now he has explained this to a general audience in the electric universe and they all got it. You don't need to know advanced mathematics to be able to see the flaws in the thinking that go into black hole theory and general relativity. And I recommend following him up on the web if you would like to get a hold of his papers. This is his comments after the event. I spoke at a conference in Prodvino, Russia. I made it so simple, and this is what he's very good at, that all understood and they were very displeased. During question time, they went on the attack but could offer no counter-arguments and instead tried to evade the issues. Now, this is exactly the kind of thing that I discovered at university. Others told me, and get this, that I should not criticise if I did not offer an alternative theory. That's just crazy. I mean, science is about testing, and if you get disconfirming evidence, then that should be a spur to more inventive ideas and an advance in science. The idea that you have to have an alternative theory to replace one that you're discrediting is nonsense. Nobody would talk to me afterwards. So what did they collectively decide to do in the end? Pretend that nothing has changed and go on regardless. The following couple of days were about black holes, the Big Bang, and everything that he had just discredited. business as usual. Now, one of the people who were inspired by Velikovsky, and in turn inspired me, since I was looking for answers to how all of the things that Velikovsky had described could have happened, is Ralph Jurgens. And I saw him in action at a conference in 1974. That was my first real contact with him, but everything he wrote I devoured because he was a very thorough researcher, and his insights I thought were almost as amazing as Velikovsky's. Since then, some things we now know, in fact at the time the neutrino count was also a problem, and it continued to be a problem for decades until somebody managed to find some kind of story to cover the problem. There's the solar wind acceleration still remains a mystery. The super hot corona is still a mystery, although many people think they have a solution. Solar activity cycle, still a mystery. The solar convection has been found to be practically absent, and this is supposed to drive everything that we see going on above the sun. And the heliospheric boundary, the interface between the solar system and interstellar space, has also defied all expectations. And this has been good for me because I've been describing what I felt would be found out there, and so far it matches. This is the time that I met Velikovsky. It was the first international conference on the recent history of the solar system. Now, according to astronomers, of course, there is no such thing as a recent history, especially not within mankind's term on this planet. That's a photo I took of Velikovsky from the front of the hall, but you can get an idea of the audience there. He was able to draw quite a crowd from around the world. Of course, his challenge to the mainstream was that, as he said in the opening pages of his book, Worlds in Collision, if Newton's laws are sacrosanct, this book is a heresy. And the response of the professional astronomers at the time was to ignore the gauntlet that he'd thrown down and just say Newton's laws are sacrosanct. And just you can ignore the rest. What we now think we know is that our solar system appears to be weird when compared to planetary systems around nearby stars. Uranus and Neptune could not have formed where we see them. So now you'll see papers appearing frequently talking about rearrangement of orbits, the possibility of an extra gas giant having been present initially, which then somehow managed to push two of the other gas giants, which became Uranus and Neptune, further out into the solar system. And also, when we look out at the exoplanets, they appear to be impossible according to the standard theory of how our solar system was formed. So there's a severe problem in even explaining why we're here. Now, the organisers of that conference appear on this page. On the right is Stephen Talbot, that's Dave's younger brother. It was he who I wrote to, and he was the main correspondent that got me to the conference. He invited me to come over. It was there also that I met Dave Talbot. At the time, neither of us knew what the other was up to, and in fact, I'm not sure that we knew what we were up to. But it turns out that we'd both been inspired by a short paper that Velikovsky had written about the idea, the outrageous idea, that Saturn featured as a sun in early human memory. And that idea, to me, was the genesis of the idea that the solar system is not only changed, but it's actually a work in progress. It had formed by the capture of other objects. I was an avid reader, of course, of all the Ponce journals. They were extremely well produced, and that was the vehicle that got me to the US, to Canada for this meeting. Then it was 20 years later. I had David's book, The Saturn Myth, and a friend of mine said, I'd like a copy, and I said, well, I'll see if I can contact David. When I rang David, it was just serendipitous that it was the year that he had organised an international conference in Portland, Oregon. And after I inquired about the book, he said, have you got anything you'd like to present at this conference that I'm about to put on? And I said, yes, I have. And so I was invited to that conference, and it was there that the collaboration began. There was another scientist who was involved with Ralph Jurgens towards the end of Ralph's life. He was an associate professor at the University of Lethbridge in Alberta, Canada, Dr. Earl Milton. His main training was in spectroscopy. He came to Australia and stayed with our family, his family, and he joined us at the time that Halley's Comet was in the sky. He felt that the southern skies were the best place to view it. He wrote at one point, what goes on inside stars is a sort of fantasy, which we all subscribe to because none of us have seen what happens inside stars. All we can observe is the radiation that emerges from the star's surfaces and what happens to the atmosphere transmitting that radiation. And being a spectroscopist, the next statement is of significance for the electric universe model of the Sun. The major solar spectroscopic identifications represent much more dense materials than implied by the defined density of the Sun. It implies that what's inside the Sun is not what we think it is. He was also well aware of the problems that we faced. The conspiracy of silence, which was imposed by powerful scientists in 1950 upon Velikovsky's work, remains essentially intact today in the halls of academia. That was in 1983 when he and I were both in London. Nothing's changed. I had the privilege in 1979, that's 5 years after the conference in Canada, to be in Washington, here, working for the Australian government for a few weeks. And I rang Velikovsky at his home and mentioned the fact that we'd met at the conference and would it be okay if I visited. He and his wife graciously took me, my wife and 3 daughters in for the afternoon. And my main question to him was, it centred around this problem of what don't we understand about gravity and Newton's law. Because this was critical, and his view was that there was electromagnetism somehow involved in the process. So he gave me this small monograph which was published in 1946 called Cosmos Without Gravitation. Now the title is a bit misleading because gravity exists, of course, and I think it's useful to maintain the distinction between gravity and the other forms of the electric force, that is magnetism. But in that book he gave a clue. In the theory presented here, this attraction is not due to inherent gravitational properties of mass, but instead to the well-known electrical properties of attraction. 2 dipoles arrange themselves so that the attraction is stronger than their mutual repulsion. Now, chemists know this because all of the visible world that we live in depends upon this dipole-to-dipole interaction. And when I went back, I thought I'll have a look at the difference between the chemical textbooks and the physics textbooks to see just how close the chemists were to the answer rather than the physicists. And it was striking. The physics textbook had only a cursory derivation of the forces between dipoles. The chemical one went into great detail. You know, charged particle to induced electric dipole to induced electric dipole, and so on. There was about 6 or 7 different versions, and each one had a slightly different equation to describe it. And it's significant, I think, that certain well-known scientists in the past, Fritz London was one of them, suggested that gravity might be the same kind of intermolecular force, the thing that holds the solids and the liquids and so on together, that gives us the world we exist in. But this was the clue. It had something to do with electric dipoles, which in neutral matter still attract. So 2 years later, 1981, there was a tiny advertisement in the Scientific American for the Journal of Classical Physics. The first article was by Ralph Sainsbury. It turns out he was the originator of this journal. and its title was Electron Structure. And I thought, well, this is if we're talking about electric dipoles and the electron has structure, this is the first place to look. And so I contacted Ralph, and we actually met in London shortly after. Now, I enjoyed Ralph's derivation because it is simple. It's a case of a repeated pattern. You take the atomic structure and you suggest that perhaps subatomic particles have this similar structure. And because atoms can be distorted to form electric dipoles, that means that subatomic particles can also be distorted to form subatomic dipoles, and the resulting attraction between them, because of the difference in size, which is colossal, gives you the reason why gravity is 10 to the 40 times less strong than the naked electric force. Anyway, he derived Ampere's law from this simple model, and I thought that was an excellent start. But one of the requirements of his theory is that the electron stability requires that all of these particles communicate amongst one another near instantly. Otherwise, you cannot hold the electron together. It's not coherent. And that speed of the electric force is colossal. This type of mechanism explains gravity simply if you involve all particles in this process. It explains Mach's principle, this idea that all the matter in the universe is connected. Only here you have all the matter in a galaxy is connected in real time. And it discards all of these virtual particles, the wave-particle duality. The speed of gravity. Tom Van Flandern, who attended many of our early meetings, he showed simply that the speed of gravity exceeds 20 billion times the speed of light. Now that was a lower limit. If that weren't so, a torque would fling the planets out of the solar system in a few thousand years. It's because we would not be orbiting where the sun is, but where it appears to be in the sky, and the result is the force is coming from an angle which tends to act like your slingshot. So his view and his simple observation fits Sansbury's electrical model of gravity. And he argued also, a separate argument, for the origin of comets and asteroids from an exploding planet. He felt they had a common origin in some event. The year 2000, it was about September, I think, we had a very significant meeting of the electric universe proponents in Portland, Oregon. And at that meeting there was the astronomer Halton Arp, there was Tony Peratt, the leading plasma physicist, Tom Van Flandern was there, and we had scholars involved in the mythological aspects, and Professor Don Scott. So we had two former Sagnac Award winners at that meeting. This is the kind of meeting it was. It was really outstanding. But the most significant thing there was that Tony Peratt, who worked at the Los Alamos labs, had access to information that no one else did. And that was the form of plasma instabilities when you create the most powerful electrical discharges that man can do on Earth. And when you do that, you get the kind of forms like that one seen in purple on the right. And because the plasma is semi-transparent, certain aspects of it, the edges, become strongly visible. In fact, sometimes the light from this can be so intense it can actually be lethal. It ranges up into the X-rays. Just faintly behind that you see some of the weird figures that have carved on rocks around the world. The Australian Aborigines have their own lightning man and Wandjina figure, which they describe in ways which is associated with lightning and with power flowing down from heaven. And they're very careful to choose their words when they say these things. So all of this fitted with the Saturn model. And of course the Saturn model, when on first appearances, is so outrageous that it's easy to dismiss it. But here we had hard evidence, very hard, it was carved into rock, that ancient man had witnessed about 80, or most of the 84 different forms of this instability. Of course, Halton Arp is a key figure because he has dealt with the grand scale of the universe, the cosmology. He provided the physical link between high redshift quasars and low redshift active galaxies, which shows that redshift is largely an intrinsic factor in a celestial object, like a galaxy or a baby galaxy, a quasar. And this gets rid of all of the problems which are ignored by astronomers with things having to be ultra bright, ultra massive, and all this kind of thing if you place them at the end of the universe. But if you bring them up close with the things that they're associated with, they become normal brightness, normal sizes, and everything appears okay. I find it quite odd that astronomers can make these leaps and just say, well, it must be huge, it must be really ultra bright. We don't understand how you can generate that much energy to see it at that distance. One of our key members in the early years was Amy Aitchison, and she used this little cartoon on the left. Objects in the mirror are closer than they appear, and this is the case. In other words, the universe, the visible universe, is much smaller than we think. It also appears to be relatively static, according to Halton Arp's reconstruction. This means there was no Big Bang. The universe is of unknown age and extent. We can say nothing about origins. And really, it is very arrogant of us to think that in the last microsecond of our scientific endeavour that we've uncovered the secrets of the universe. This is something that Halton Arp said to those of us that he was associating with. He's always had a keen regard for amateurs and those who are prepared to ask questions. I hold him in the highest regard. The greatest part of the progress independent researchers have made in the past decades, in my opinion, is to break free of the observationally disproved dogma of curved space-time, dark matter, Big Bang, no primary reference frame, and no faster-than-light information. All of these things I agree with. If you get his book, Seeing Red, he, in the final pages of the book, ticks all the boxes for the electric universe. We arrived almost at the same place, coming from slightly different directions. The electric universe story adopts successful plasma cosmology, and this is one of the other aspects of specialisation in science today. The IEEE recognises plasma cosmology as a discipline and it publishes papers on it. Astronomers do not attend the meetings and they don't read the papers, except for one, Gerard Vasseur, the radio astronomer. He was at one of the meetings with Tony Peratt, and we were there as well, because I have had some papers published in the IEEE Plasma Journal. And they were excited over the fact that Gerard Vasseur had found the radio signatures that were expected from this image on the left of the screen. This is a picture of the Birkeland current filaments that flow between galaxies in deep space. They're in what's called dark mode, so that you can't actually see them, but the radio astronomers can pick them up with their radio telescopes. Now, you will see just down from the top of the slide, there's a small inset saying cross-section of galactic Birkeland current filament pairs. When two of these Birkeland filaments come close together, they begin to interact and draw closer together. And early in the interaction, you'll see the two filaments draw in towards one another. There's a long-range attraction and short-range repulsion going on. On the right is a picture of Markarian 739, and here we're looking down the barrel of two of those Birkeland current filaments coming together and beginning to form a spiral galaxy. Simple explanation. What does NASA say? Galaxy boasts two monster black holes. It just goes to show how disconnected and unpredictable and useless modern cosmology is. The electric universe story explains the mass and energy focus of galactic centres very simply. The current flowing along the spiral arms of a galaxy in towards the centre must go somewhere. And in the laboratory, when you pour electrical energy into a discharge which converges on a point, the result is what's called a plasmoid, a dense plasma focus. And that's the shape that it takes. It's like a donut with a complicated path that the electric current flows in, but down the central core, all of those filaments are closest together. So what happens is, as the energy is more and more concentrated, there comes a point when the particles there start colliding more and more. And at that point you have neutrons being formed which can escape, and these plasma focus plasmoids are the most copious source of neutrons known in the laboratory. And they also then decay into protons and electrons, of course. Now the electrons tend to get trapped for longer than the heavier particles, so the protons escape, and the things that are formed along these huge jets are electron deficient. They are the quasars. Now the fact that they're electron deficient means that their polarization will be lower than another galaxy or its parent. And the result of that is that the masses of the subatomic particles involved are lower, their redshift is higher, and the energy involved is less, so they're faint. All of this fits together in a simple electrical explanation. You do not need a black hole. The mass there is simply there because E equals mc squared. If you keep pouring more and more E in, you'll get more and more m. And these plasmoids are extremely small. I would say in the centre of our galaxy it's less than the size of the solar system, which is unresolvable at that distance. There are no black holes, as Stephen has shown theoretically. The electric universe story explains the electrical formation of stars and planetary systems. In the laboratory, in these intense discharges, what happens is that the discharge breaks up into blobs, often 7, I think, or 9. And after the discharge fades, they scatter like buckshot, was the term that Tony Peratt used. And what do we find in deep space? When you look through the dust using an infrared telescope, you find the stars are arranged in these, along these filaments. They're the Birkeland current filaments. What's more, it's been discovered that these embryonic stars flicker, and they flicker far too rapidly for matter just falling in and causing radiation to outbursts. So that's a problem for any theory of stellar formation using gravity. But of course, electrical circuits often flicker. So these stars are flickering as electrically as they accumulate matter. Professor Don Scott and I are currently working on what is the exact circuit, because this is fairly complicated. This is the circuit connecting a star to the galaxy. This one is lit up and is known as a planetary nebula. And you can see the wonderful complexity in there, but we're beginning to unravel it. We're also trying an experiment to test it. If it's confirmed, I think that's worth a Nobel Prize. Not for dark energy or the cosmic microwave background and all this sort of thing. So this is the circuit that connects a star, and this is what we're working on now. This is the reason why all of the models of what would be found at the boundary of the sun's electrical influence, at the heliosphere, has not been met. None of the models worked, but the one that looks at it from this electrical circuit point of view, which I've tried to do, still matches what's being found. I think this is great confirmation for the electrical model of stars. Here's Don, and Dave did a great job yesterday of showing some of the technical aspects of Don's work. It shows the transistor, a style of interface between the sun and what's above the sun. And it explains it all simply in electrical terms. Simplicity is the key. Now, one of the most amazing parts of the story revolves around the Saturn myth. David's work, Ev Cochrane, Eduardo Cardona have all worked on this. It's been a life's work for them as well. The big problem was, how on earth do you stack planets pole to pole in a line? There's no known stable orbital system that will do that. I thought about that for decades, and finally, piece by piece, I managed to sort out the puzzle, I think. What I've shown here, coming down from the top left, is a red dwarf which has entered the sun's electrical environment. The two heliospheres have touched, and then when that happens, they see each other electrically. Now, the sun is treated in the electric universe as an anode, a positively charged body. A red dwarf is a much less positively charged body. It's glowing dimly. So when it enters the sun's domain, it becomes a comet. It switches from being an anode to a cathode, and a cometary appearance is characteristic of a comet. Also, there are electrical forces start to apply in the form of modification of the mass of the objects in that brown dwarf system. The change is such that it tends to capture the objects. It draws the star away from its satellite so that they spiral down and trail behind the main object. It's a bit like Comet Shoemaker Levy 9 when it disintegrated. They didn't just form a cloud of particles, they formed a chain, a line. So all of the very high energy discharges that we have examined and got confirmation from Tony Peratt, I feel, were when we were sitting in the tail of the comet. That was one huge electrical discharge. And it wasn't just us that was in it, but the other satellites of Proto-Saturn, we call it, the brown dwarf. And it's interesting that in recent years, astronomers themselves have come to the conclusion that the most likely place for life in the universe is as a satellite of a brown dwarf. There's much more to that in the electric universe model than there is in the standard model, which makes it even more likely. The other thing that you have to worry about is when you've captured all of these bodies, it must be total chaos in the solar system. All of the orbits have to be adjusted to achieve stability. And that's when I came up with this idea that all planets in the solar system act as secondary electrodes in the sun's discharge. They are less positive than the sun, they are therefore cathodes. They emit electrons. In the case where they're all drawn into the current sheet of the sun, and we know that each of the planets has what's called a magneto tail, a cometary-like tail behind it, and there are charged particles involved because of the magnetic fields. The charge transfer appears to work in such a way that when two bodies come towards one another, the inner one tends to move in towards the sun and the outer one tends to move away from the sun, so they space themselves until the electrical interaction ceases, or almost ceases. In the case of Mars, you still have the things like the ionospheric blue clearing occurring when Mars ends up in opposition to the Earth. You also get those global dust storms. They're all explained electrically, and it's this electrical transfer between the inner planet and the outer planet that spaces them and stabilises the system. So that's my contribution, electrically modified Newtonian dynamics, I call it. It's very simple. The equations are just involved high school physics. It explains the electrical capture, the avoidance and rapid orbit stabilisation. It explains the transition of the captured system from a brown dwarf to a gas giant. It's no longer a star, and it has to adjust to its electrical environment, and that may involve flaring, violent outbursts, just like comets. They tend to disintegrate to some extent. So some of the bodies in the solar system, one in particular, Venus, appears to have been a part of that electrical readjustment. Of course, a recent National Geographic has our wild, wild solar system, and here we have an object colliding with the Earth to form the Moon. This kind of thing in the electric universe is most unlikely to happen, because long before the two planets get anywhere near that kind of contact, they will separate electrically. Eduardo Cardona is one of the key authors of the Proto-Saturnian story and has traced back the history as far as, or further than anyone else, I think. And his talk at the Electric Universe conference was Strangers in a Foreign Stellar System. and his books are a mine of information. The electric universe story, as Steve Smith very ably demonstrated yesterday, can explain the origin of these vast electrical scars on Mars, because it was heavily involved in all of the activity. Mars, the god of war, he actually suffered worse than anyone else. The electric universe story pieces together the dramatic recent story of the Earth and its inhabitants, our catastrophic past and the fact that we have not yet come to terms with it. And our popular astronomy gives a distorted view of the universe. The modern vision evokes a sense of lonely bodies in space, isolated galaxies, self-immolating stars drifting like dust motes in the blackness, and the clockwork solitude of planets. It's a hopeless cosmology. In challenging this idea, the electric universe emphasises connectivity. The electric force influences matter at all levels, from subatomic particles to galactic clusters, leaving little room for the disconnected fragments of modern theory. So it's all about connectedness. The electric force operates in real time. All matter is connected resonantly by the electric force to produce quantum effects. As soon as you get rid of the speed of light delay, you can begin to understand the weirdness of, or the so-called weird aspects of quantum theory. Nuclear forces, magnetism and gravity are all manifestations of a single force. And these simple concepts are essential for coherence on all scales, from the galactic to the solar system to life on Earth and down to atoms themselves. It is based on inspiration, interdisciplinary inspiration, and this is really interdisciplinary. A lot of people pay sort of lip service to it, but the EU uses it as a basis, a foundation. It's not consensus in a specialised theoretical field that ignores, and I quote from the earlier advertisement for Lawrence Krauss, unsubstantiated and bland myths pervaded by the ancients. The electric universe story was inspired initially by Velikovsky, and the inspiration continues. No one assumes in this group that we have all the answers, and we're keen for anyone else who feels they can lead in some area, because it's a huge picture that we're building, are welcome. I feel one of my dreams is to see a reconstruction of the human story going back to the earliest times, the view of creation. What were these creation stories really about? Because obviously no one was around when the universe was created. These are stories about the creation of the world we see today from something that was different before. If we could just have an IMAX movie, I think people would get it. You wouldn't have to labour the point. The symbolism and everything comes down to today. And that symbolism is striking, it's undeniable, and I think people even at a subconscious level would connect with it. And once we've done that, Velikovsky felt that the most important message is that unless we understand our past, we cannot heal from the wounds of facing doomsday. I can't even imagine what it must have been like in those days to feel that the world was just about to end. We suppress that memory, and until we can learn what it was that the ancients were desperately trying to tell us with their monuments, their strange artwork and their strange stories of gods and things going on in the sky, until we understand that, we cannot heal. Velikovsky felt that was the most important message he had for mankind, because otherwise, unless we can heal, we cannot begin to behave as perfectly rational denizens of the universe. And our future on this planet is questionable. Thank you.